Welcome all. So in this video we are going to learn about the Kubernetes architecture. Actually many people doesn't know how the Kubernetes workflow and the requests drive inside the Kubernetes cluster. So with architecture we are going to discuss now. Okay. So first, what is a Kubernetes? Kubernetes is a container orchestrated tool which is a cluster environment. It is mainly responsible for state of cluster and making decision about the scheduling and the scaling. Okay. Let's understand that the first Kubernetes components is, as you all know the basics, and there will be a master node, right, which we call it as control plane, which we call it as control plane. Now let me reduce the size. Okay, so this is nothing but a master node. Okay, and this control plane is completely managed at the cloud environment. If you can take it EKS or AKS and GKE, so this is completely managed by the cloud only, cloud provider only. So inside we will be having one called Kube API server. So what this Kube API server is do, let me reduce Kube API server, Kube API server, and we have other components like Kube control manager, okay, and we have another one also which is Kube scheduler, and we have another one is etc. Okay, so these are the main components as we know, but how does it actually works all these components? So first I'll tell you from the first component is API server. So this API server actually is a front end to your Kubernetes. It is actually a front end to your Kubernetes, and all components, internal or external, every component inside this Kubernetes cluster need to be communicate with the API server first. So it has to communicate with the API server, and it is uses RESTful API. Okay, RESTful API over HTTP connection, HTTPS connection. It is going to be connect on RESTful HTTPS connection for secure communication, and it will do three, okay, which is triple A. So authorization, accounting, and authentication for admission and control management. So it do all this Kube API server only. How we'll be discussing in just coming few words. So this AAA is going to be handled here itself in the Kube API server. So it mainly works on RESTful API or HTTPS secure connection. Okay, so let me demo this. And control manager. Here in this control manager, what happens? So in this control manager, it basically manage your control of controlling the main node. Okay, it is a node controller, deployment controller. It always communicates with your Kube API server to monitor the states and resources. So what are all there, it is going to be trying to communicate with the Kube API, and it will look for your node controller and deployment controllers. Okay, always. So this is going to be communicate with this is going to be communicate with this is going to communicate with this, and the scheduler. So what the scheduler will do, this scheduler will decide where the pod need to be run on in which node. Okay, where the pod has to be run on which node according to the resource availability and the policy. So it always fetch a specification from the API server, and it will run in the appropriate node. So that means let me remove this board is something. Okay, now I'm having this a big one, so this is my cluster. Okay, so this is my cluster actually. So in this cluster I will be having two worker nodes. So this is your node pool group, and entirely I can call this one as a cluster. Entirely I can call this one as cluster. Okay, so it is a network, a logical network. Okay, it is a logical network which everything is reside inside this cluster, and there will be a this one control plane, and this is the node plane. We call what it is a node plane. Node plane. Okay, so in this node plane you are going to run these components. You are going to run these components. Okay, so in this node plane, what are all the components will be presented? So there will be a one kubelet, and there will be a kube proxy, and there will be a kube proxy. So same way in your second node also, here it is, and in your second node also it will be there. Okay, and atop of this, so there will be a runtime. So there will be a runtime. What is the runtime? Runtime means it is Docker container runtime. Okay, on top of this there will be a pod. There will be a pod. So this is pod. So inside the pod there will be a container. Inside the pod there will be a container. Okay, so this is pod. So let me and write down this. This is a pod, and inside that there will be a container, and this is a container. Okay, this is a container. How this is going to be communicate means, see, your Kube API is going to communicate with your controller. Okay, and your Kube API is going to communicate with your scheduler, and your Kube API is going to communicate with the etcd also. Okay, so with everything it is going to communicate. With everything it is going to communicate. Now what happens here, your Kube API is doing the authentication and it use the RESTful API, so the HTTP connection, right? And now this is going to communicate with all the components inside your master node, and your control manager will control the node controller. Here there will be controller over the node, which nodes are there, and the deployment controller. So the pods are going to be deployed here, so that is a deployment controller. And so it ensures that the communication with API server and to monitor the state resources. Okay, and your scheduler. So what the scheduler will do, this scheduler, when your pod is going to run in this node, so it has to run in this node or it need to be run in this node. So this scheduler is going to decide where this pod has to run, in this first node or in the second node, or in the first server or in the second server. And coming to etcd, etcd is a local database. It is a local database. It is a local database. So where it is storing distributed key value for cluster data. So it is a single source of truth for the cluster. So the API server always communicate a direct communication with the etcd to read and write the cluster state things. Okay, so whatever the state of this cluster, everything it is going to write, this kube API is going to write in this etcd. Okay, and now coming to the worker nodes point of view. So here you have the kubelet. What this kubelet will do? So this kubelet is an agent which is going to run in every node. If you have a 10 servers inside the cluster, if you have the 5 servers inside the cluster, so those are the nodes. Okay, so those are the nodes. So this control plane and this node plane will be connected, and now there will be a kubelet. So this kubelet, in each node it is going to run, it always trying to communicate, it always communicates with your API, with your API, always communicate with your API. It always going to communicate with your API kubelet. So why it has to communicate means to ensure, okay, so it communicates and to receive the pod spec. First of all, pod spec, the specific configurations about this pod, whatever the pod is going to run inside this node. So about the specifications, this kubelet is always go and communicate, and it will receive the specifications, and it will ensure the pod should be run in this node. So that is the main responsibility of a kubelet, and it will monitor the node. It will look into the node and the pod status. It will look into the node and the pod status. If something is wrong, that status kubelet will update to the kube API server. Okay, kube API server. So this is the main role of kubelet. And again, there is a kube proxy. So what is this kube proxy will do? Kube proxy is manage a network rules and the nodes. So it is basically, it is going to enable your service discovery. That means it is enabling the communication between pods across the nodes, pods between the nodes. Okay, kube proxy and enable the communication between the pods between the nodes. Okay, this service. Okay, it actually uses one called IP tables. IP tables, nothing but IPVS for route traffic. For routing traffic, it uses this one. Okay, this kube proxy. And coming to the container runtime. So in this container runtime, you can also use Docker or CRIO. So it's basically responsible to pulling the image from your registry. If you have some registry here, from here it will pull, and it will trying to run it as a pod. It will trying to run it as a pod. And now when this communication happened with this kube API to etcd, and there will be TLS. Okay, so it is a secured one. API server writes everything, read cluster state to from etcd. Okay, and so it is also secure communication between your controller and your scheduler also. So everything will communicate. And now how this exactly happens? Now here you have a laptop. Okay, here you have a laptop, and you are connecting to the cluster, so when you're connecting to the cluster, first you will going to connect to the kube API. So here you're going to install kubectl. So this is a command lead kubectl. And when you are running this command kubectl get nodes or get pods, so it is trying to communicate with your kube API server. So while it is going to trying to communicate, and there will be a kube config file. Okay, kube config file, so that is going to authenticate authorization. This file is going to, this is going to store in your laptop. If you go to your programs, there will be a file. So this is going to be communicate with this kube API, and this is going to communicate with this kubelet, and this is going to communicate with your pod, and it will bring the specifications, and it will come to your this one, and it will show to you. But before that, so whatever the state it is, the state is there, right? So this state is going to already store in the etcd, all specific state configurations. So first what it will do, so it is cube API will go to the etcd, and whatever the data is present here, it is trying to fetch, and then it is trying to show to the user who is an engineer who's connecting to this side. Okay, and how the communication will be happen. See, you have a two ports, for example. So these two ports will be communicated by using the CNI, which is nothing but container network interface, CNI. By using CNI, it is going to communicate. Now you have the some application running inside your pod. Okay, inside your pod, then how it is going to be used. See, we have the three services. One is cluster IP, and one is node port, and one is load balancer. Okay, so we have these three services. So what happens in the real world? What happens in the real world actually? So you are going to configure an ingress, an ingress. So this ingress is having a load balancer with your DNS. Okay, load with your DNS for path based routing, and all your workloads except the front end. So one front end will be exposed with the load balancer, and all your backends will be exposed with your cluster IP. So that, so whatever you are going to do here, so here we are going to write some path. Okay, write some path. When an end user enters into the cluster by typing www.abc.com/login, okay, /login. So the request first, it will come to the your UI, and then it will reach to your UI pod. And if it is a payment, then it will go to the payment, and then it will reach to the payment pod, and it will the some order, and then it will reach to the order pod. So like this, the path based routing will be happen by using ingress and load balancer when a user search this one. So this is how it will enter inside your ingress, and then it is enter into your pods, and there will be again specific configurations we do external to internal communication. So ingress and the load balancer services will be used, and we will be going to route the appropriate pods to the service layer. Okay, so this is how this works, and in our Kubernetes masterclass we are going to see all this lively, how the communication be happen and everything. Okay, thank you, stay tuned and subscribe if you understand. If you're not getting this one, just please post your question, then we can answer your question.